Welcome to lesson 3.4. We are going to be talking about atomic weight, atomic mass, atomic number, a little in more detail than we did in the last lesson, but just some terms to define and some things you need to know about the atoms. Because atoms are so small, it's not like you can put them on a scale, right? Um, so scientists needed a way to talk about the atom with scientists around the world. So there needed to be a standard, right? Just like there's a standard unit of measurement for length, the meter, for mass, the gram, for time, the second. But there needed to be something standardized so that all scientists around the world would know what other scientists were talking about, right? Um, so we have to come up with a standard. You can see this in so many examples. We had to come up with a standard for money, right? People just couldn't use whatever they wanted for money. There had to be a standard that was universal around the globe. And so the modern system of atomic mass, which was created not too long ago, about 60 years ago in 1961, um, carbon became the standard. And we're going to abbreviate that C12. But carbon 12 became the standard, which means that what scientists did is they took that carbon 12 and assigned it a mass of exactly 12 atomic mass units. So carbon weighs 12 atomic mass units, right? And scientists just, worked together and came up with this and said, this is going to be our standard. Just like whoever, economists or whoever, came up with, okay, we're going to have a dollar, it's going to have 10 dimes, 100 pennies, 20 nickels, 4 quarters, right? I mean, they just picked it, right? It seemed to work, so they picked it. Same here. It seemed to work, so they picked it, right? All other atoms' masses are measured and calculated against this standard, right? So if the standard is a dollar, then everything else, 4 quarters, 20 nickels, whatever. But everything else is relative to this standard that they picked, right? Like an hour is a standard, 60 minutes, 3,000, ever how many seconds, 3,600, sorry, um, 24 hours in a day. I mean, it's just the standard that is picked for time. So this was the standard that was picked for the weight of atoms. So, in order to compare the masses of different atoms, scientists use something called mass spectrometry. That's a hard one to say. Let's spell it Trometry. Mass spectrometry. We will talk about that in a future lesson in more detail. Um, so, um, if we have a sample of an element, um, there might be different, what we call isotopes. Basically, an isotope has the same protons. Remember, that can't change. Different neutrons. So, same number of protons, same proton number, different neutron number. Um, so, you might have a sample of a bunch of different carbon atoms. They will all have 12 protons, but some might have 12 neutrons, some might have 13, some might have 14. You've heard of carbon 14 dating. To find out how old something is, carbon 14 just has 14 neutrons. Um, because there's all those different, there's 12, 13, 14 neutrons, each of those atoms will weigh differently because 12, carbon 12 has 2 less neutrons than carbon 14, so it's going to weigh differently, right? So what they do in lab calculations, they find what's called an average atomic mass. So when you look on a periodic table, and you are looking at the atomic mass. I'm trying to find a periodic table real quick here that I can show you because I forgot to get one together. But when you look at a periodic table, the number that you see that is the mass of the atom is the average of all the different isotopes. Haha, okay, I found one. So when you look at a periodic table, this number here is the, as you can see, we'll look at this example, is the atomic weight. Remember, here's the atomic number. This one doesn't happen to have the mass number written on it, but that's okay. But the atomic weight is an average of all the different isotope weights. So when you look at your periodic table and you see those, the numbers here, that's the average atomic mass of the elements. So like we said before, carbon was used as the standard. The mass of carbon 12 is 12 AMU, or atomic mass units. And if we look at a sample of carbon, 98.89% of the atoms are carbon 12. So the parts that are carbon 13 and 14 are minuscule, right? Just a little bit more than 1%. So the mass of carbon 13, remember we said it was measured with that mass spectrometry, is actually 13.0034 AMU, atomic mass units. And about 1% of the atoms are carbon 13. Right? So in order to find the average atomic mass, to take the average of these two things, basically what you do is you take the percentage, which is 0.9889 times 12, and add that to the percentage of the other, 0.0111, that's 1%, times 13.0034. And when you add those together, you get 12.01 AMU is the average mass of carbon. And if you look on the, sorry guys. If you look on the periodic table and you go over to carbon, you see 12.01 is the average atomic mass of carbon. Because you have this much of it is 12, this much of it is 13, add them together, and you get the average. So scientists use this average as the weight of carbon. No single carbon atom actually weighs 12.01 atomic mass units. It's an average, right? And it helps us simplify things and also to remember that not all carbon atoms are carbon 12. Some of them are carbon 13.